Hey guys, hope you've had a good day so far. Today we'll just be running through some questions about investments and loans, a topic you'll find in the Year 12 Standard 2 course. So let's dive in. Our first question is about future value. So Hodges invests $340,000 for 10 years at 4.75% per annum, interest compounded quarterly. And Daniel also invests $340,000 for 10 years, but his interest rate is 4.75% per annum compounded monthly. A, calculate the value of Hodges' investment at maturity. So applying our formula of FV equals PV, 1 plus R to the power of N. So our future value is what we're trying to calculate after the 10 years. Our present value is $340,000. Our R is given as 0.0475 and our N is given as 40. So how we got the 40 was because it's compounded quarterly, so you've got 3 months that make up the whole year, or 3 months in each period that make up the whole year, so it becomes 4 quarters. The rate is also divided by 4. So that now we just have to apply it to the formula. So we've got FV equals 340,000 in brackets 1 plus 0.0475 on 4 to the power of 40. And this should just give you $545,197.13. So that is the amount or value of Hodges' investment at maturity. Our next question is asking, show that the compounded value of Daniel's investment is greater than the value of Hodges' investment. So we're doing the same thing again, applying the same formula, but one thing that will change is that his interest is compounded monthly, not quarterly. So in that case, still rewrite the formula, PV 1 plus Rn. Now our PV is still the same, 340,000. But our R is going to be divided by 12 this time. And similarly, our N will be 120 because it's 10 years and 12 months. So 12 times 10 gives us 120. Now we just apply that into the formula again. We'll get 340,000 in brackets 1 plus 0.0475 on 12 and then to the power of 120. And when you plug into the calculator, you should get around about 546,212.4414, and that just comes to 546,212.44 to 2 decimal places. Now we can see that the value of Daniel's investment compared to Hodges' investment is greater. So we'll just write a quick statement. Daniel's investment is 546,212.44 at maturity, which is greater than Hodges' investment of, it was 545,197.13 at maturity. And there you go. And our last question is saying, explain why Daniel's investment is worth more than Hodges' investment. So the reason for this is that, well, Daniel's investment, I've spelled that wrong. Daniel's investment is worth more because of the power of compound interest. So there's more periods in Daniel's investment. So we can say because of more compounding periods, which means more interest and more frequently. Next question is looking at appreciation and inflation. So the cost of a certain car has increased during the past 3 years from $55,700 to $60,988 following inflation. What was the annual inflation rate? Answer to the nearest 2 decimal places. So in this scenario, we would still use the same formula as we did before. So FV equals PV 1 plus R to the power of N. Now our future value is given, which is 60,988. Our present value is also given at 55,700. We need to find the R, so we don't know the rate yet, but we do know the number of periods, which is 3 because it's 3 years. Now we'll just plug that in again, so you'd get 60,988 equals to 55,700 in brackets 1 plus R to the power of 3. Now if you rearrange that, you should get this. Minus 1, and then that will give you roughly 0.03069 dot dot dot, and if you convert that into a percentage by multiplying that by 100, that will just give you 3.07% inflation rate to 2 decimal places. And there you have it. Next question's about shares and dividends. So the question is asking, a company posts an after-tax profit of $78 million. There are 100 million shares in the company. What dividend per share will the company declare if all the profits are distributed to the shareholders? So in this case, we want to apply our formula, which is dividend per share is equal to total after tax profit over total shares. And so in this case, our total after tax profit is given as $78 million. So we just put that on top. And then our total shares are 100 million. So we just put that on the bottom. And then when you plug into the calculator, should come up as 0.78. So that means our dividend will be 0.78 per share. For our last question today, we'll be going through a declining balance depreciation question. So it asks, a new car is valued at $40,000. After 1 year using the declining balance method, it is valued at $32,250. A, determine the annual percentage rate of depreciation. Answer correct to 3 decimal places. So what we want to do is use our declining balance formula. S equals to VO, bracket 1 minus R to the N. S is our current value of the item, which is 32,250. We've got our VO, which is 40,000, which is essentially how much it was bought for. And then R is what we're trying to find, and our N is given as 1. Now we can apply this to our formula, so you get 32250 equals to 40,000, 1 minus R to the power of 1, and if you rearrange that, you should get 1 minus 32,250 on 40,000, and that will give you R equals to 0.19375. And if you want to convert that to a percentage, you just times it by 100, and that will give us a total depreciation rate of 19.375% to 3DP. And then our next question is asking, what is the value of the new car after 3 years? Answer correct to the nearest dollar. Now we want to go through year by year. So in year 2, we would get 3250 times the depreciation rate, which was 19.375%, and that gives us 6248.4375. So this amount is essentially how much it has depreciated in value in year 2. To find the final balance, we just subtract that from the current value, 6248.4375, and that'll give us a value of 26001.5625. Then in year 3, we'd apply the same rule. So we'd get 26001.5625 times the depreciation rate, 19.375%, and that will give us 5037.8027 ... So in year 3, this is the amount that it reduces by or depreciates by, and then we subtract it again from this figure here. So that minus 5037.8027 ... and that will give us roughly $20,963.79 ... and then if we just round that out to the nearest dollar, yep, so it asks correct to the nearest dollar, that would give us $20,964 to the nearest dollar. And that's about it. Thank you for watching.